Chapter 2 is solving equations. Big ideas here: equivalence, solving equations and inequalities, and proportionality. We want to know, can equations that appear to be different be equivalent? How can we solve equations? And what kind of relationships can proportions represent? Section 2.1 is solving one-step equations. I can solve one-step equations in one variable. Big ideas here: equivalent equations are equations that have the same solution. The solution of a one-step equation can be found using the properties of equality and inverse operations to write a simpler equation. Take note, addition and subtraction properties of equality on page 81. The addition property of equality tells us that adding the same number to each side of an equation produces an equivalent equation. And our subtraction property of equality tells us that we can subtract the same number from each side of an equation to produce an equivalent equation. So as long as we do something equal to both sides, it stays equal as far as adding and subtracting go. To solve an equation, we have to isolate the variable. We do this by getting the variable with a coefficient of 1 alone on one side of the equation. We can isolate a variable using the properties of equality and inverse operations. An inverse operation undoes another operation. When we solve an equation, each inverse operation we perform should produce a simpler equivalent equation. So our goal here is to get simpler and simpler and simpler equivalent equations until finally we get something like x equals 7, for example. In example 1, we're trying to get x by itself. So I need to get whatever else is on that side equal to 0, because x plus 0 is how I get to just x. So if I subtract 13 here, 13 minus 13 gives me 0, and x plus 0 gives me just x. I have that x alone on the left side like we tried to get. It's isolated. But whatever I do to one side, I have got to do to both in order to keep it equivalent. So since I subtracted 13 on the left, I have to subtract 13 on the right, and I get down to 14. So here x equals 14. To check that, we plug it back in. So I'm going to take 14 plus 13 and check. Does it equal 27? Here it does, so we know that we are right. Same idea here in example 2. I'm trying to get b by itself. The only thing I want on that side of my equal sign is b. So in order to do that, I have to add 3. Okay, I get rid of a minus 3 by adding 3, because negative 3 plus 3 gives me 0. And b plus 0 gives me just b. b is isolated completely by itself. Now, again, whatever I do to one side, my properties tell me I have to do both to keep it equivalent. So here I get negative 4 equals b. And if I check that, I can plug it in. Negative 7, does it equal negative 4 minus 3? And we get negative 7 equals negative 7. It checks. We are correct. Now, feel free to pause here and give these a try if you'd like. We want to find the solution of each equation. Right now, I have y plus 2. We check and see what's happening to 2. Well, we're going to use inverse operations, things that undo each other, to get rid of it. So to get back to 0, which is what I need, I have to subtract 2. So to get rid of a plus 2, I minus 2, because 2 minus 2 is what gets me to 0. And anything plus 0 is itself. So here I get negative 8. And if we plug it in, negative 8 plus 2 does equal negative 6. Same idea. I'm trying to get m by itself. So to get rid of a minus 8, I have to add 8. And whatever we do to one side, we do to both. Minus 8 plus 8 is 0. So all I have left is m on my left side. On my right side, I have negative 6. If we plug it back in, negative 6 minus 8, does it equal negative 14? And here it does. So we are good. Works the same way here in C, even though it's fractions. Well, y is being subtracted, so I have to add to get it back to 0. Whatever I do to one side, I do to both. Negative anything plus the same thing always gives me 0, whether they're fractions, whether they're whole numbers, whether they're decimals, doesn't matter. And here I have half plus 3 halves. When I add fractions, I get a common denominator. Here I already have one, so I keep it. And then I can add along my numerators and get 4 over 2. 4 divided by 2 is just 2. So here we get 2. And if we plug it in, that does check. We could use the multiplication and division properties of equality to solve equations as well. The take note on page 83 talks about our multiplication and division properties of equality. We can multiply each side of an equation by the same non-zero number to produce an equivalent equation, and we can divide each side of an equation by the same non-zero number to produce an equivalent equation. So these are very, very similar to our addition and subtraction properties of equality in that we have to do them to both sides. The only difference here is that we cannot multiply or divide by 0 on both sides. Okay, so everything else is fair game, but we can't multiply or divide by 0. Here, we want to know what's the solution of 4x equals 6.4. Well, x is being multiplied right now, so to get that back to be a coefficient of 1, we have to divide by 4. Remember, anything times its reciprocal or anything divided by itself gives me just 1. So right now I have 1 times x, which is just x. And whatever I do to one side, I have got to do to both. So when I divide there, I get 1.6. If I plug it in to check, 4 times 1.6, does it equal 6.4? And here it does. So we are good. On example 4, right now x is being divided. Remember, fraction bars represent division. So if I multiply both sides by 4, that's how I get to 1x, which is what I want. 4 divided by 4 is 1. Anything divided by itself is just 1. And whenever our coefficient is 1, we know it's just 1 times anything is itself. We just get x. And since I multiplied by 4 on the left, I have to multiply by 4 on the right, and I get negative 36. And if we plug that in and check, are they equal? Here they are. Now, feel free to pause here and give this a try if you'd like. What is the solution of each equation? Well, here, to get x by itself, I have multiplication. We get rid of that by dividing. Multiplication and division are inverse operations. They undo each other. 15 divided by 15 is how I get to 1 times x. Again, just gives me x. 1 times anything gives itself. Here I'm going to simplify this if I can. 10 and 15, I can take a 5 out of both of them. And when I do that, I'm left with 2 over 3. And when we plug that back in to check, we get 10 equals 10. So we are right. On B, I have multiplication. So to get rid of multiplication, we are going to divide. And it doesn't matter that that's negative. We take the sign with the number the same way. So here, negative 3.2 divided by negative 3.2 gives me just 1. Anything divided by itself gives you 1, and 1 times z is just z. Keep in mind, they both have to be negative in order to give us just a z. Then, if I take 14 divided by negative 3.2, I get negative 4.375. And we don't round there. And since we started with a decimal here, it's okay to give it as a decimal. Or you could have had negative 4 3/8 or negative 35 over 8. That would have worked as well. In C, to get r by itself, we look, and right now we have division. To get rid of division, I'm going to multiply. 3 divided by 3 gives me just 1, and 1 times r gives me r. Whatever I do to one side, since I multiplied by 3, I have to do to both, and I get 57 equals r. If we plug it in and check, 57 divided by 3 does give us 19. We are correct. Same idea here with D. Right now my variable is being divided, so to get rid of division, we are going to multiply. And again, we keep that sign with our numbers. So if I multiply on the left side by negative 9, I multiply on the right side by negative 9. Negative 9 divided by negative 9 just gives me 1x. And anything times 1 is just itself. On the right side, I get negative 72. And again, if we plug that back in, it does check. When the coefficient, or the number in front of the variable, in an equation is a fraction, we can use the reciprocal of the fraction to solve the equation. Usually whenever we have multiplication, we're going to divide to get rid of it. But when we divide by fractions, we multiply by the reciprocal. So we can go ahead and do that right away. So rather than dividing by 4/5, I'm going to multiply by its reciprocal, which is 5 over 4. And when I do that, we multiply fractions straight across. So I get 20 over 20m, and anything divided by itself is just 1. So here I have just m. And it works the same way as if we would have divided by 4/5, but when we divide fractions, we have to multiply by the reciprocal anyway. So here that cancels out. Since I multiplied by 5/4 on one side, I have got to do the same on the other. Remember, we write whole numbers as over 1 and multiply straight across. So I get 140/4, which simplifies down to 35. Now, if we plug this in to check, I'm going to take 4/5 times 35 and check, do we get 28? And here we will. So it checks we are correct. Give this one a try if you'd like. Right now, my x is being multiplied by a fraction. So rather than multiplying or then dividing to get rid of it, I'm going to multiply by the reciprocal, which means my numerator goes to my denominator and my denominator goes to my numerator. And whatever I do to one side, I still have to do to both. 3 divided by 3 and 4 divided by 4 both cancel, so all I have left is an x. My 12 I can write over 1 and I multiply straight across. I get 48/3, which reduces down to 16. And if I plug that back in and check, 3/4 times 16, does it equal 12? And yes, it does. So we are good. Toucans and blue and yellow macaws are both tropical birds. The length of the average toucan is about 2/3 the length of the average blue and yellow macaw. Toucans are about 24 inches long. What is the length of an average blue and yellow macaw? So, tells us that they're birds. That's cool, but we don't really need it. The length of a toucan is about 2/3 of the length of a macaw. And I put arrows there just because we're talking about two different lengths. So right now I have length for toucan means equals 2/3 of means times and length of the macaw. Then it tells us toucans are about 24 inches long. So toucans length R means equals 24 inches. So toucans are 24 inches. We want to know what is the length of the macaw. So here toucans are 24. To get our m by itself, I can multiply by my reciprocal to get rid of that multiplication by a fraction. And whatever I do to one side, I do to both. So 2 divided by 2 and 3 divided by 3 both cancel. And I just get 1m or m. We multiply across and simplify, and I get 36 inches for the length of a macaw. Check your answer doesn't seem reasonable. Here it says toucans are smaller than the macaws. 2/3. So macaws should be more than toucans, and here that's what we have. Now, an online DVD rental company offers gift certificates you can use to purchase rental plans. You have a gift certificate for $30, so we have $30. The plan we select costs $5 per month, which means 5 times the number of months. How many months can we purchase with a new gift card? Well, right now my m for month is being multiplied. We get rid of multiplication by dividing. And again, whatever I do to one side, I have to do to both according to that division property of equality. 5 divided by 5 gives me just 1. So 1 month. So every month, months equal 6. Sorry, so it's going to be 6 months that we can buy. Quick recap here. Equivalent equations are equations that have the same solutions. And the solution of a one-step equation can be found using the properties of equality and inverse operations to write a simpler equation. And that's all I have for section 2.1.